Today we are going to talk about web service design. It's a very strange topic and it's going to be really bits and bytes technical. Okay, so this is not one of those overview, hi-fi, high level things which we sometimes cover. So this is going to be absolutely from the trenches kind of details. So let me sort of try to put today's talk in context. Okay, so what is it that we are going to cover and at what level and so on. So we are going to focus in this series on how to design web services. So we are going to look at, once you know how to design, how to write web services, you want to have the next level of understanding, the next level of consistency and approach and other finer points which help you do a better job on building large applications. So we will aim for having a consistent set of our conventions of how we design web services. We will be covering some tricky areas, pointing out some areas, some approaches which helps you debug things. And all in all, we've landed up with 20 topics, big and small, some which will be covered over 10 slides, some which will be covered in exactly one slide. So a combination of all sorts of topics. It's a kind of potpourri of topics, all related to designing web services. Now, in the next few minutes, I'll explain what the purpose of this series is and where exactly it aims. Okay. The first assumption we have is that we assume that you know how to code web services. It doesn't matter which programming language, you know SQL, you know how to write web services, you've written plenty of them, and you have some familiarity with at least one or two frameworks like Django for Python or Gin for Go or Spring Boot for Java or whatever it is. Another assumption is that we are living in a world where everything is JSON. So requests and responses are all JSON. And our series are going to cover the topics independent of any server-side programming language. Okay, so it doesn't matter which language is your favorite. We are going to cover the general principles. And of course, this talk is purely for web services, web service design, web service implementers. This is not going to touch upon front-end code at all. Now, I'd like to give you a little bit of background about where we come from. See, we have been building large business applications since maybe 1994, 1995. Definitely since 1996. So we started writing browser-based applications, as in my colleague Kishan Parekh and I were doing browser-based applications using CGI, using the NCSA HTTPD before Apache was a popular player on the web server scene. We've been, I remember Kishan leading a large amount of software application development using Perl CGI. He was a Perl whiz, so Perl 4, Perl 5. We built large applications using Perl CGI. We were very thrilled to discover fast CGI. And then all sorts of other programming languages, PHP, Java. We were probably the first Indian team to do online real-time credit card billing. I don't know whether any of you even remember a company called CyberCash. So we were doing CyberCash-based credit card billing in 1994. So in those days, we were building browser-based applications, but it was all server-side rendered pages. The pages are HTML comes out of the server, ready-made. So that was not web services. And then we, of course, transitioned to web services via all sorts of intermediate things, PHP, Java servlets, what have you. And later on, I think, I'm not sure, but we probably started doing web services after Struts 2 at some point. I'm not very clear, but at least 15 years ago or so. So we have like 30 years of application development experience, and we have gone through various stages of this. So the first stage was when we were actually developing applications, browser-based applications. Then we were leading teams where others were developing browser-based applications, and we got an appreciation of what trips up a young software developer and what we need to do to make sure that the code they write is robust. Then we got into the next phase of our maturity, where we started designing web services so that others could develop them. So from leading a team for execution, you go to the design role. When you start designing, you get the feeling that you need to learn what you need to specify so that the developers can understand the specification and execute in a reliable way. From designing web services, we moved to the next step, where we started framing guidelines for others to design web services, for others to develop web services. So we have frameworks and guidelines. Using those, designers, senior developers and designers write the design and specification for web service calls, and then after that we have developers who pick up those specifications and implement web service calls. So we've gone through all these layers of maturity. Now we have understood that you may know how to write a web service call, especially young developers have written many web services. They know how to write the code for a web service, but they probably are struggling with what choices to make when they have 5 different ways of implementing web services, right? So the same pie can be sliced and diced in 20 different ways. So you have all these challenges, all these choices to make. So our series is going to address that level of mature developer who's faced with designing of web services. Now that he understands how to develop them, he's done a lot of web service development, he wishes to move to designing and specification and standardization. So what we are trying to cover here are the set of standards, the set of the conventions, the templates, the standards which we have evolved, which we follow for all our projects in Remigis. So we want to share all of these things with you. Some of these are supported by code. We have libraries, we have frameworks which we have developed, all of which are open source. So you can actually pick up ready code to use or do the things the way we do them. So that's one. And there are certain things which are not about code. They are about you designing your web services to follow the approach that we follow. So there you'll have to just go through the series and see what we do and how we do them. So before we get into the guidelines that we have in Remigis for designing web services, let me share with you some of the written down standards that we follow. So this is at a level, one level or half a level lower than the guidelines. Okay. So we have certain very specific standards about how we structure a web service request, how we format or what is the data structure we use for a response, how we report errors, how we actually report a value, etc., etc. For successful web services and so on. So let's look at the standard. These are actually in written down documents on our internal wiki, and I'll share some of the screenshots from some of those documents. So before we get into that level, you'll have to excuse I think there's some background noise, you'll have to excuse that. We just can't cut out 100% of the noise, so that's okay. I'm sure my voice is audible. So when we look at the specification of a single web service, what are the parts that we insist on? These are part of our standards. So web service specifications are written in our company. Designers and senior developers, actually the lead engineers as we call them, they actually write web service specifications for each and every web service, where each and every parameter in the request or the response is documented. So The specification of a web service includes one block called the request, the next block called the processing section, where we describe what processing is done in the web service, and the third block called the response. So these three blocks are mandatory. And in the processing section at various places, we also specify what will be the error codes which this web service can possibly return. We've specified the list of SQL statements that this web service will use. We specify some things about what is logged. Logging is a very important part of the life cycle of a web service, and we also specify editable configuration parameters. Editable configuration parameters are an important dimension of the business applications we develop. We'll talk about them in due course a little. Request section. Let's see what goes into a request. Now, this is a screenshot from our internal documentation. It may or may not be very readable in your screen. That is not important. Okay? I'm just giving you a sample of what we have written down in our specifications, internal specifications. How do we define how do we specify the request of a web service? So we have, every web service request will have a JSON block which will have a block called data, an object called data. Inside that object will be all the request parameters. So it could be one, it could be multiple. Sometimes it could even be zero. There are ultra unambiguous web services which one can sometimes design, where they do exactly one job and they do it without looking at any request parameters. So the entire data block can be empty. So the data block will carry the request parameters. In addition to the data block, there will be typically at least three more things. One, there will be a JWT. Almost all web services will be authenticated, so there will be a JWT. And this is usually not in the data block, it is outside in the HTTP header. That is the authentication token. The second thing which will be there will be a version number. The version number is typically, we use an integer as a convention. So, like version 1, version 2 and so on. So each web service can have multiple versions, and the version number is also included typically in the URL or in a parameter outside the data block. So this version is not going to go to the web service, to the code of the web service. It is going to be used to decide which version of the web service code to be triggered. And the third data point or datum which we pass in every call is this trace ID. The trace ID is generated by the front-end code and is usually incorporated in the HTTP header. This trace ID is picked up on the server side and logged, so that we can trace the sequence of all the activities that are happening in one web service invocation. So these are three things that are part of the standard which always are supplied with every web service. So I was telling you about this. The JWT is the first, then the version number, and the third is the trace ID. Okay, these are the three things which also have to accompany every request. So as you can see, the trace ID that we usually use is UUID. So we will use some UUID generation library on the client side, which will generate a unique UUID every time it triggers a web service request. So that becomes the trace ID. So this is a sample of a request. A sample request will have various parameters. The earlier one that I showed was just a data block which had only one value. Here we are showing the data block which has multiple fields or multiple parameters. So this is usually how we write our specification. We will write this data block where we will have all the parameters listed in legal JSON syntax. Okay? And we will also document the meaning of each parameter. So that's about requests. Now let's look at the processing section. The processing section is like the internal meat of the web service. What does the web service do after it is triggered, after it receives a request? So this is what a processing section does. The first thing it does is it checks the JWT. Is the token valid? Now the token can be invalid in two ways. One is completely invalid, one is sort of invalid. Okay. The first is the token signature has to match. So the token itself has to be not garbage, which means we have to know that the token was issued by our IAM, by our authentication layer at a previous point in time. So is the token basically valid? If not, if the token doesn't exist or the token is not valid at a basic level, we return an error code which we call authn, for authentication, AUTHN. Next check is the token may be valid in structural sense, in the signature sense, but it may have expired. So if that is the case, then it's not that the caller is an out and out fraud, it just is that he needs to get a new access token. So his token has expired. So we will then return the error code auth exp for expired. So these are two different error codes which mean two different things. Authn means authentication failure. Either there is no token or the token is structurally invalid. Auth exp indicates it is a valid token which has just incidentally it has happened to expire. By the way, can you hear the sound of rain? So we are in one of the heaviest rainfall days of 2024 in Bombay today. So some rain sounds are going to accompany our awesome web services exploration. Treat it as web services in Malhar. Okay. So basic checks. After basic checks, we have the next check, which is authorization. I am assuming you know the difference between authentication and authorization. So if authorization checks fail, then the web service will return the error code auth-z for authorization. That was auth-n, this is auth-z. So auth-z indicates you are authenticated, you are a legitimate user, your token is valid, but you don't have the rights to do what you're trying to do. So that's auth-z. After authorization checks, the next is input parameter validation. So there will be a long laundry list of your input parameters, and every parameter will have to be validated. Sometimes simple syntactic validation, and sometimes deeper cross validation. After input parameter validation comes the actual business logic. So when we write the business logic in the specification, we try not to write much. There is a very important dividing line we have to always be cognizant of, which is have sufficient documentation to make sure that the next developer can read the documentation and understand the boundaries of your web service. But don't have too much documentation. Don't spoon feed the developer, because otherwise the effort to write good documentation begins to exceed the effort to write code itself. It sort of becomes self-defeating, right? If you take more time to prepare for a meeting than to do the meeting itself, you begin to wonder, whether the trade-offs are making sense. So when we write business logic documentation, we try to make it sparse, but there are a few things we do try to specify. Where there are complicated database access patterns, we specify transaction boundaries. In the spec, we will write where we will begin the transaction, where we will end the transaction, and if there are multiple transactions in one web service call, we specify begin, end, and so on. The second, we specify the SQL statement ID, the SQL statement ID. Every SQL statement used anywhere in a business application we develop has a unique ID. So you can look at the list of SQL statements of any of our applications, and you will know exactly how many different SQL statements are being used. It could be 55, it could be 220, whatever. Each unique SQL statement has a unique ID. So we specify the SQL statement ID in the documentation, ID or IDs in the documentation. We specify all the constants and configuration parameters by name. We'll come to these parameters a little later. We specify Redis keys if Redis is being used for caching. The exact key template will be specified in the web service specification, so that the developer knows this is the key format, or this is the structure of the key he has to use, and he will never have to invent his own. So this is what we write in the processing section. So this is one example of a processing section where the pseudocode in the beginning is basically just doing authorization checks. So all sorts of checks are being done, if then else, and the code is deciding what this user can do and cannot do, and whether he has the rights to do the operation that he is attempting to do. So sometimes authorization checks can be fairly complex, so we capture them here. This is just a random example. I am not trying to go line by line through this to make any generic points. This is just an example of how we write our specs. After the processing section comes the third section, which is the response section. Here we specify what response we will return from the web service. Now, our standards for web service response have one data structure of a particular type which is returned when the call is successful, and another data structure which is returned when there is an error or there are errors. So this is an example of success. Whenever a web service written by a remiges team returns a success status, the response JSON will have the following three parts. The same three parts are there in all web service responses. The first field is status. It will have the value success or error. So that's the first field. The second field is data. The data block will contain actual values which are being returned in the response. So if the response is pulling out some data and returning them to the caller, then that data will be in the data block. The third element is messages. Messages is an array. Now, messages is an empty array if the call is successful. If the call fails, which means the status is not success, then the data block will typically be empty and the messages array will be full of error messages. Let us see what that looks like. This is what that looks like. See, the status has now become error. The data block is now an empty object. And look at the messages. The messages is an array of objects, each of which has 3 to 4 fields. Well, it can have a minimum of 2 fields. So the messages array will have objects. Each object will have 2, 3, or 4 fields. This is very standardized in all applications we develop. We also have libraries which allow us to generate these data structures and process them, which means we generate them in, say, Java or Go, and we process them in JavaScript. So the code exists, and no developer in remiges really deviates from these ready-made libraries and modules. So it's like ingrained into our DNA. This is how we do many things of web services, including the response format. Let me explain the messages structure. Every message has to have like a human readable string, right? Like the voucher date is too far in the past. You cannot enter a backdated voucher. Suppose that is an error. Now, if that is an error, that is a message. That message has to be a string. Now, if we return that string as part of the error of the web service, then that string becomes hard-coded. It cannot be indexed for language. So error messages have to be indexed by language and by the message ID. So we return the message ID. So if you see this example here, message ID 235 refers to a message in our message table. And the message table will have a list of all error messages in English, a list of all error messages with the same meaning but in some other language like Hindi, a list of all. So depending upon what the application does, the developers will keep adding messages into the message table, which they will maintain separately in an Excel spreadsheet. That spreadsheet is used to generate JavaScript code and other code, etc. That comes later. But the point is, every message is identified by a unique ID, and if you go into the message table and indexed by language, and then indexed by the message ID, you will get the actual human readable string of that message in that language. So this has been standardized. We always return message ID, okay, and the message ID is always an integer. The next field that you see is an error code. This error code is a one-word English string. It gives the client code or the front-end code or the calling code a broad idea of the nature of the error, which means if something is missing, if a mandatory parameter was missing in the request, then the error code will probably be one word missing. If a mandatory parameter like a telephone number was supplied in the request, but the data that was supplied does not match a telephone number format, it does not have those whatever number of digits, etc., format that we look for, then the value here will probably be invalid. The error code will specify a word data invalid or invalid. Okay. So error code gives a broad idea of the nature of the error. It does not give an exact idea. The exact idea will only be understood once you read the message string corresponding to the message ID, because the message string is human readable. This is for programmers. So the error code becomes very useful for programmers for the front-end programmers to look at the error code and sort of take a broad decision what to do. For instance, auth n is an error code. If auth n comes as an error code, it means there is an authentication failure. So he doesn't need to look any further in the error list. He knows that authentication itself has failed. The web service call was a no-go. Okay? So he can take broad decisions based on that. The third field in this object, which is optional, is a field. What field indicates is the name of a parameter in the request. So here the web service is telling the caller that this error pertains to XYZ field. So the example we have shown here is max delay. Max delay, we presume, was the name of a field in the request, and that field had an error. So this error, the first error in the array, refers to the data provided in a request field called max delay. The second error in the array refers to a field in the request called full name, and so on. So this is how the calling code can correlate the error that it is receiving with the field that it specified in the request. Now there are certain errors which are not relative to any field, not connected with any field. Those errors will not have the field attribute at all in the object. So you'll only have message ID and error code. You won't have a field attribute at all. So field attributes are only there when a particular error refers to a particular field in the request. The fourth attribute, vals. Vals is an array of values, array of strings. Now vals can also be optional. Now where does vals come in? Vals comes in because sometimes the error message has placeholders. I'll give you an example. Suppose that there is an error message which says the voucher value is too big, maximum acceptable value is 20,000. I'll repeat, the voucher value 33,000 is too high, the maximum acceptable value for a voucher is 20,000. Now look at this error message. Okay, the voucher value 33,000 is too high. This 33,000 is actually a value which has to be inserted into the string. So the message actually is going to say voucher value underscore underscore val1 underscore underscore or some template like that is too large. The maximum acceptable value is underscore underscore val2. So the message string by itself will have two sort of tokens or symbols which will have to be replaced with the actual values before the message can be shown to the human user. So the message string will have placeholders, and the values from this array, the vals array, will have to be we'll have to replace those placeholders to make the entire message string readable or meaningful. So the message string can be a template, and the values go and plug into or are injected into the right places in the message string template. So the message string that we use sometimes is a constant, it has no placeholders, and sometimes it has placeholders. When it has placeholders, those placeholders are replaced by values from the vals array. So this is the structure of error messages. We have arrived at this after a few years of fine-tuning the process. This takes care of all sorts of web service calls, all sorts of web services for all sorts of applications. It is completely generic, completely extensible, and it also has support for internationalization, because the message strings, which are human readable, are indexed by language. So the entire set of constraints or challenges which go into reporting the result of a web service have been pretty much taken care of by these measures. So this is the data structure we use for reporting errors. Actual response specification. This is an example of a real web service call, real web service whose specification had been written, and look at what it says. The response will either report errors or will report success. A success response will carry no data. So this is one of those web services which does not generate any data in the output. So when it succeeds, it will carry no data. When it fails, these are the possible errors which it can generate. These are the error codes. We have already seen in the previous example that there is a field in every element of the messages array. There is a field called error code. Those error codes are listed here. This particular web service can return these various error codes. So, this is probably a user create web service. So the error code exists, can be returned if the username already exists. Is the error code perm, which we said is auth-z. The error code perm can be returned, or auth-z can be returned if the calling user does not have the access rights to perform the operation, and so on and so forth. So these are error codes which are documented against the response of the web service. This is one example of a web service. This is another example of a web service which returns a fair amount of data. Now here the documentation says that the data block which will be returned will contain one array called user list. The data block will contain an array called user list, and the user list will be a list of users. And against each each element in the array user list, there will be these 4 fields. So that is what has been documented here, and these will be explained in the documentation further. If you go to the original source where I picked this up from, you will find that there is documentation about the meaning of each field, etc., etc. And if you look at this, this says that this shows the messages array to be empty array. Why is that? Because this is the JSON example of a success return. When our web services return a success, the messages array is empty, and the data block contains values. So this is what is being shown here. So these are conventions which we very strictly follow and are very consistent across programming languages, across applications, across project teams. Here is a list of common error codes. So if you look at most web services in most applications, you will come down to like a common set of maybe 15-20 error codes which are being reused for every possible type of error most of the time. So look at some of these. The auth error is for authentication. I have explained that we use AUTH-N. This is a slightly older standard where you used to just use AUTH. Now we have split AUTH into AUTH-N and AUTH-Z, 2 different types of authentication authorization conditions, which are 2 different error codes. Then the next one is authentication expire, so token expiry, so auth-exp. The third error code, which is often returned by many web services, is try later. The try later error code is returned under 2 conditions. One, you are hitting the web service too frequently and the rate throttling code in our server-side stack has detected that there is too high a frequency of requests. In that case, the web service will not even be triggered. The web service business logic will not even be triggered. An outer layer will track the web service request frequency. That rate throttling code will be triggered, and it will return from your request with a response saying error code, try later. What this means is you are trying too frequently, come back again. So that is one condition when you will get try later. The other condition when you will get try later is if you are making a web service call and the system wishes to inform you that the same call should be repeated after, say, 30 seconds or 1 minute because the data is not yet available. So there we will, in the later episodes of this series, we will talk about situations where we need to do this. We have situations where web services deliberately return try later, telling the client code, hey, we have accepted your request, we are processing the request, the data will be generated, come back later and check again with us. So that's a try later situation. These are examples of too big, too small, too new, too old, too many, etc. These are all error codes which can be returned depending upon the situation. Too big will be returned when the value is too high. So error code too big will be, suppose you are trying to enter a voucher of $10 million and the system does not accept a voucher of value more than, say, $1 million. So you'll get an error too big. Too small will be something of the opposite nature. Too old will be if you're trying to access data which is too far into the past, or you're trying to create a new voucher but giving it a backdated date which is too far into the past. So you might get a too old error, and so on and so forth. So these are typical examples of errors of that kind. This is not an exhaustive list of error codes, but after an application or two, one can generate a fairly exhaustive list of error codes. Because after you'll get a list of 15, 20, 25, and you'll typically not need to increase that basic set beyond a certain number. So this is our error code story. So we are at the end of episode 1. The next episode will start and take the story further. Thank you.